Thank you very much. Hopefully you can hear me all right. Give me some kind of noise if that's the case. Okay, perfect. All right, let's see if we can advance these slides then, if that's going to work. There we go. Look at that. Okay, so this is my background. Those of you who were brave enough to come to the physics talk last week saw most of this. There's one little change on my CV for tonight, and that is that I did organize a conference on artificial intelligence in Ireland that was held in March of 2019. Turns out Ireland has a lot of AI businesses and AI work, and that was a really fun conference. And I did that for the professional engineering, or it's called Chartered Engineers in Ireland, Professional Engineering Association for the country of Ireland. And that was a really fun conference. And I have the necktie from that conference that we had made. So thought I'd wear that in honor of tonight. All right, so here we go. Is AI going to take over the world and displace humans on an increasing basis? So we're going to briefly look at the current state of AI implementations and the things that are in development, noting what can and cannot still be done. And we'll look at some perspectives on what the future may hold. Now, an apology in advance. These slides have more text and fewer pictures than the physics slides. So of necessity, I'll be reading more material in it, so to speak, although I will do my best to paraphrase and keep it brief. So apologies for that. So here we go. All right, so this is our basic outline. We're going to look at AI in the news and media. We'll look at what is AI for those of you who aren't familiar with really the mechanics of it and how it works. We'll talk about current uses of AI, including some very popular ones that are new. We'll ask if this is intelligent. And of course, that will depend on your definition of the word intelligent, won't it? And then we'll look at where this is going. So this is the top level outline, and each of these bullets have some sub-levels. So the first one here will have some things on current trends. All right, so AI is in the news all the time recently. And of course, it started out really in 1927 with its first movie. We'll show that in just a minute. But television shows and so forth. We'll look a little bit at AI as it's used for voice recognition devices that you might have one of more of these in your home. All right, we'll look at some of, well, at least it's been in the news with respect to game playing. That's kind of passé now, really. It's into the category of old news. But there are a lot of big companies heavily invested in AI. And if for no other reason, people need to be aware of what's going on, because these big companies who have a great deal of influence, particularly in the cyberspace, internet, information transmission world, have a great deal of influence. We'll look at the fact that there are many new organizations forming around AI, and we'll talk just briefly about some government actions. All right, so 1927. Since then, there have been 109 movies. Now, I did a talk for this group in 2016 on AI. I think I stood in that very room or one like it when I did that. And at that time, there were about half this many movies out there. So literally 50 or more movies have come out in the last 7 years, doubling, what was available. And you may recognize many of these titles. There's no need to spend time here looking at them, and we'll talk about a few of these in particular as we move further on. All right, of course, it's in television. Person of Interest, Westworld, Humans. Many of you may have watched many of these, Black Mirror, and these movies, particularly the Impossible Things, very interesting uses of AI in these movies and television programs. So we see this a lot. Of course, then you've got your home devices. Here's Amazon, Alexa, and Echo. And these are some of the advertising comments by the manufacturer, Amazon, of these products. You can use it just using your voice, hands-free control. It's got far field, meaning it's able to detect voice even in a reverberant environment, such as a kitchen typically tends to be. It'll answer questions and give you all kind of information and tell you what the news is. It'll play music. It can control lights and other devices in the house. Anything that's considered a smart device, meaning it's Wi-Fi connectable or Bluetooth connectable. They claim it's always getting smarter, adding new features, and plus interfaces to Uber and Domino's. You can order pizza, call a car to come pick you up, etc. All right, and of course, this particular product has many competitors listed at the top here. Siri says you talk to it like you would a friend. If you're talking to Siri like it's a friend, we need to have a conversation about how you're doing. It's tuned into the world, it claims. Interesting statement, isn't it? Google CEO said that we're thoughtfully applying AI across all of our products. All right. Cortana is your digital assistant. There's Home Blue or Home Assistant Blue, and there are many more. Wait 10 minutes and there'll be a new product that claims it uses AI. This summit was held just a couple of weeks ago, July 6th and 7th. I think it was in Geneva. That's where it was held. But a lot of human-esque looking robots is what was the focus of this particular conference. Hanson Robotics has a great many of them. It's a Chinese owned and based company with an office out of Boston. Interesting titles for some of their robots. Here's Grace, all right, healthcare robot. A Cornwall University group and engineering group called Engineered Arts has a Mika. And here's Nadine. Now these last two, Nadine and Geminoid, look like their creators. So I'm not sure what that says about their creators, but that's an interesting thing to observe. So these things are in the recent news. This is just 2 weeks old. All right. In terms of current trends, there's kind of new tricks every month, particularly related to language or video. Now, right now, large language models, which is what ChatGPT is called. Now, we're going to come back to ChatGPT in some detail, so stay tuned. Don't go away. But machine translation from one language to another is one of the capabilities of these large language models. And this is the big press right now by these companies that are listed here. And there are a great many, of course, business acquisitions related to AI. And if you look at the numbers here in general, 400 million, 600 million, 7.1 billion. That's the biggest acquisition I've seen down there by Panasonic. And I'm not very familiar with Blue Yonder. I'd have to go Google them and pay attention. But 10 billion is what Microsoft recently invested in OpenAI, who are the manufacturers of ChatGPT. All right, so let's talk about business. First of all, right now, today, AI has everybody enamored in the business world. They all feel like they need to leverage AI in some fashion for their own business. And this doesn't depend on what your business is. It can be trucking, it can be in the healthcare world, it doesn't matter. Big businesses in particular, this is the current trend. There's the perception, at least, and the blatant marketing that AI will add more usefulness or value to your products. And as a result, businesses themselves are being evaluated differently in terms of their AI proficiency. How good is your business at integrating AI into whatever your business world is? And I'm not making this up. This is straight from Wall Street analysts who are saying this. So are we seeing a whole new generation of software being built and sold Yes, we are. And here's a good example that uses these large language models, copy.ai. If you go to this website, they claim we'll be your ghostwriter. Whatever you need written, we'll write it for you, or the machine will. And look up what it ought to be. So this is becoming an issue, particularly for those who are supposed to be writing their own writing. They go get the AI to do it for them and turn it in as their own work. So plagiarizing or fraud of another type is occurring in many places. Very interesting. Here's the issue though, and this comes from, this is an Axios article. I've got, by the way, sources at the bottom here, and those of you who would like a copy of these slides, you're welcome to them. And then you can check out these sources yourself. But part of the difficulty, according to many writers, especially from the business finance side of the world, is that they're having trouble with how the word AI or artificial intelligence itself is being defined. What really is it now? So ever since neural networks came along, and we'll talk about what those are here in a minute, AI has effectively become synonymous with efficient pattern matching on a large scale, and I'll describe what is meant by that. So based on that definition of AI, that it's a pattern matching machine, then Google search engine, iPhone's face recognition, Facebook being able to recognize your mother and all the photographs you post, all right, well then that's AI driven and has been for years. And many in the finance world are crying overstatement. You know, they're crying foul that because AI is so popular, everyone wants to get on the bandwagon right now. ChatGPT, in particular, has become an attention-seizing program. ChatGPT, for those of you who don't know much about it, or those of you even that do, was released in November of this past year. And it's the fastest growing online app ever. So we'll look at why that is. But ChatGPT is part of the broader field of generative AI, and it is impressive, but you'll see that it is limited and how it's limited. This is a curve that Gartner Group, now the Gartner has been around for decades. They are a financial analyst company. You pay to get their information typically, and they publish things openly, only in small bits and pieces. This is something they developed 2 or 3 years ago called the hype cycle. This is a real thing for new technologies. So if you look on this particular chart, I'm not sure how well you can see the small print. I've tried to keep most of the print big so it's readable in a group setting like most of you are in. But you notice how things start off on the left-hand scale. The y-axis are expectations. Now this is from a business finance point of view. All right, and then it comes up to a big peak. Do you see what that peak is called? The peak of inflated expectations. And then there, after that, of course, when things don't meet up to those expectations, you have a drop off in interest, or at least in the expectations that people have of things, and then some type of stasis or a long-term plateau of productivity is obtained or attained. So right here is where generative AI. Now, by the way, this chart is almost, well, it's a full year ago. It was as of July last year. So I couldn't find a newer version of it, at least that Gartner has published. So this is dated information, but you can see where a year ago, before ChatGPT came out, they already had generative AI up very close to a peak of inflated expectations. Be interesting to see what they say now. Notice where deep learning in general is, and we'll talk about deep learning. Right next to it is autonomous vehicles. We'll talk about those. And over here is what's called artificial general intelligence. It's not even gone up the hill of big expectations yet, although it's talked about a lot. All right, there's big money going into all this. Microsoft says that a top AI researcher costs you more than an NFL quarterback. Most people agree that OpenAI is leading the field. This is a company that was started by a consortium of people, including Elon Musk, who put a lot of money into it, and then it broke off independently. So right now, competitors are having trouble keeping up, but there are plenty of competitors. Here's a small group of them who are building what's called a chat bot. A chat bot, for those of you who aren't familiar, is a bot, comes from the word robot, all right? So it's a computer that can chat with you, carry on a conversation, or at least appear to. Cohere, they've got more than 440 million, and they've done so well, they were bought out by a company called Ramp. Anthropic is a big hot company right now. They were founded a year ago and valued and got investment of 4 billion. And they've released a chatbot called Claude, #2. Character.ai, $1 billion. Inflection, formed by a former Google executive, 1.5 billion. And Elon Musk just last week unveiled XAI to, quote, understand the true nature of the universe. That's what an AI company is doing? All right. So here's the thing. All of these recent breakthroughs in AI, they're all the same breakthrough. There's just really one breakthrough. And then some people are making minor improvements, and the most recent improvement we'll talk about is called attention. We'll see what attention is shortly. All of these breakthroughs have been made possible by what's called deep learning, or in general, what scientists call deep neural networks. So let's look at what this is. What is AI? And we're broken it down here into what's called traditional AI and then the machine learning or deep learning. And we'll compare these things. All right, so what is it? John McCarthy coined the term in 1955. He was at Dartmouth, and he called it the science, artificial intelligence is the science of engineering and making intelligent machines. The fuzzy word in this sentence being the word intelligent. All right, the goal is to build machines that can perform tasks that would normally require human intelligence. That was back in 1971. What it really is a collection of computer program techniques that expressly, at least traditional AI, expressly separated the knowledge from the application algorithm. So you really had a database that was the knowledge base, it was called. So the knowledge was then applied to real-time problems using an app and using a mechanism inside the app called an inference engine. So this is traditional AI. The techniques that are used are listed here. There's a bunch of them. You don't need to dig into this unless you just have interest in it. But you'd be exposed to all this in an artificial intelligence introductory course, for example. The hot area, of course, is listed at the bottom there, neural networks. All right, so first, before we get to a neural network, let's see, well, what's different about a neural network compared to traditional AI. Here's kind of a block diagram of a traditional AI system. You have this thing called an inference engine, which was similar to a reasoning mechanism. The key was that it could take the knowledge base and apply it to some type of data or input that was provided, and then give you the desired output, depending upon whether Ross, for example, it was a medical diagnosis. That was one of the first areas back in the 70s and 80s where AI was attempted to be used, was to, replace the doctor, and have the machine do the diagnosis and determine really what's wrong with the patient. But it's been used for stock market predictions and financial trends and so forth. All right, so typically you would make this thing automated and collect your knowledge base using real human experts. And they would use this reasoning system and create this knowledge base. And then the advantage of this design was you could get your expertise from multiple people, right? So that's kind of a pictorial diagram of what an AI system was. The key feature being the blue box, the separation of the knowledge from a general purpose engine that could apply the knowledge to a particular situation. All right, so let's look at deep learning. First, let's define a few terms. We've defined artificial intelligence. Neural networks are a subset. They're just one type of artificial intelligence technique. Machine learning uses neural networks and probability and mathematical techniques that help enable the machines to get better at something, whether it's recognizing an image, whether it's being able to recognize speech or speak itself. All right, you have a mathematical technique that's doing that. Deep learning is simply machine learning that has a multi-layered network, and we'll show some pictures of that in just a minute. The only thing that made it deep was the number of layers. More layers of the network than the, quote, the deeper it was. All right, so neural networks. They really started back in the 60s, and so they fell out of popularity because it, at the time, didn't seem like a good technique. The real problem was they didn't have enough data and they didn't have enough computing power. So those are the two things in the early 2000s that changed, that enabled these neural networks to work. But they're designed after a loose idea of how the brain is connected. But unlike a biological brain, where any neuron could connect to any other, at least that's nearby, in a true network fashion, artificial neural networks have discrete layers, they have specific connections, and they have a direction of data propagation. All right. So here's a simplified neural network. You have each of these round circles represents what's called a neuron, or a processing node. That's really all it is. You have a group of input processing nodes. And each of them can detect maybe some characteristics of the data. So if it's an image, maybe it's detecting, one of these nodes detects color, and the other one detects sharp contrast changes, where there's an edge and so forth. And then you have an output layer on the far right, where each output represents some kind of decision as to what the image might be. It's an image of a cat. No, it's an image of a dog. All right. So these are the output layer. But you see in the middle, you've got this hidden layer. At least one. Deep neural networks will have, based on today's design, thousands of layers in the middle here, so-called hidden layer. And each of these has its own processing algorithm. And then the idea is that as you input something that, say, is a picture of a cat, the hidden layer adjusts each of the lines, which are called the connections, and they adjust other parameters in each of the nodes to try to get that cat output node to light up. So when you use a neural network, then the knowledge base, so to speak, is in the network. It's not separated from the network. So that's what's different about neural networks compared to the traditional AI systems. But neural networks require extensive training or front-end development, and we'll look at how that's done here in just a second. One of the things that made this possible were self-correcting functions that would cause the hidden network layer to make its own internal adjustments to match the input to the known correct output. So that was how the machine learned, was it could self-adjust to correct to hit, so to speak. So let's look at how it really would work. How do you recognize a dog in a photo? And Dr. Fei-Fei Li, she's currently at Stanford as a professor and works with various companies. But She's the one that revived, or is at least credited with reviving neural networks as an artificial intelligence technique in the first decade here of the 2000s. And so here's what she did. All right. During training, you present a whole bunch of pictures, and the input processing nodes are going to look at different characteristics of that picture. All right. And then the next layer of nodes are going to look for different details. Now, this might be a curved shape. It might be a straight shape. In other words, shapes can be grouped. So if you're looking at images, you can start to define different types of shapes that matter. Then you can create another layer, and this layer is combining those shapes, and it's going to have, say, okay, this group of shapes represents a foot, or this group of shapes represents the tail of the dog, or this group of shapes represents a nose, and so forth. And then the top layer is going to be more complex, such as it's going to be closer to a four-footed animal, horse-like, dog-like, rat-like, etc. And then the outputs are the actual final decision node as to what is the image. And the whole idea is to adjust all these middle hidden layer node characteristics, they're called parameters, adjust these parameters so that the probability of it correctly identifying a dog is increased when it is a picture of a dog. So there's a lot of math involved here, where each node is going to sum the weights, and you can change these weights. That's one type of parameter. A bias is another type of group parameter, and so forth. But it's all math. This is what's being done to create a neural network. And the hidden nodes have all sorts of algorithms, whether it's some type of decision tree, clustering group, reinforcement, a Bayesian, which is typically true or false type of decisions, and so forth. All these things are called weights or parameters in general. So you see, rather than hard coding software routines that somehow magically say dog picture, the machine is instead trained. The picture is broken down into composite little pieces and then aggregates of those pieces, and weights are adjusted to give the network the ability to learn. I put quotes around these words because this is a tendency you'll see throughout this presentation, is for writers and those who promote this technology to use human terms. It's learning. The machine is learning. What do you mean by learning? Well, it's adjusting these weights and parameters to increase the probability that it says the right thing, identifies the right picture. Each neural network needs training, lots of training. And so to simplify this, or to increase the level of automation, there is a learning algorithm. There are actually a number of them now, but the learning algorithm helps to adjust these weights automatically to optimize the decision-making process. So as these weights and parameters are tuned so that the machine gets the answer right during the training phase, where it's said to have taught itself what is a stop sign if you're trying to do an automatic car driving software. Or it recognizes, oh, these are pictures of your mom, these are pictures of your brother, these are pictures of your dad or yourself in Facebook. Or pictures of a cat, which is what Andrew Nee did back in 2012 at Google. And this was, he won a competition, and that's what turned all of this stuff for neural networks on high speed, was Andrew Nee's work in 2012. Now, here's a graph that shows neural networks getting more complex. Now, some technologies, if you're familiar with Moore's law, you know that computer processing doubles every, 2 years, I think was Moore's law. This is doubling every 3 to 4 months. And this is, again, an old chart. I think this is 2021, yeah. So this chart's 2 years old, but you can see what the trend has been for neural networks, particularly for these deep learning models. There's the GPT algorithm. Now Chat GPT uses GPT-4 or 5 at this point, but 2 years ago it had 200 billion parameters that are being adjusted by this mathematical adjustment technique. All right. The other thing that's interesting is the talent it takes to design these systems. And we'll talk some more about that, but most of this talent is concentrated within what are called cloud service providers. You know their names: Microsoft, Amazon, Alphabet, Facebook, IBM, so forth. And these top 5 have more AI employees than the next 45 companies in the USA, at least, put together. So there is a big concentration of talent, and that means you have to have the money to afford that talent because it costs what a NFL quarterback costs. Let's look at some current uses of AI now that you kind of have a feel for what this stuff actually is mechanically. Now, here's a big long list. We won't spend much time here, but you can just scan over and see and maybe recognize some of these uses of AI. The writing one there is one of the things ChatGPT does, or the chatbots will do. Language translation is big, getting better. It's still not as good as a good human translator, but it's pretty impressive. And so forth, all right? And then down at the bottom, I've got autonomous vehicles. Let's talk about autonomous vehicles, because this is a good use case of how it tends to go with AI. All right. Now, this was back in 2016 when I gave this talk to TCCSA the first time. Same picture, by the way. Uber that was their little car back then, and it just did great, except couldn't figure out where to go on a one-way street. I think they've solved that now. Google's car had smashing results. This was how the news likes to report it when they had an accident in an intersection. But does anybody know of 100% autonomous vehicles? There's a few trucks. Most of them are confined to cities, which are very well mapped environments. But you can't easily go out and just buy a fully autonomous car yet because they don't exist. You still have to sit behind the wheel, and the machine is looking at you to see if you're still looking at the road. And if your eyes go off the road or you go to sleep or whatever, it's going to turn off the automation. All right. That's exciting. But this is really hard. All right. As the editorial director here for the Wall Street Daily said, as in tough science, because to make it's not just a problem with the AI or the machine automation. They have a problem with vision. They have a problem of what to pay attention to in the vision. Of course, as real humans, we have that problem, don't we? If we don't pay attention to the right thing, we cause an accident. And of course, we expect these machines to be better than humans, or we're not going to put them out there on the road. So this is tough. And as the Carnegie Mellon scientist said, you can't just assume this stuff's going to work. Well, that's interesting. Let's look at the claims in 2016. Now do the math. How many years ago was that? 7. Here were the claims about self-driving intelligent cars. Why the vehicles would just simply drop you off at your destination and they would vanish. They would know where to go, to the AI car garage. Cars would chat with each other. The cars would chat with the road and modulate the flow of traffic. Car accidents would be a thing of the past. The transportation secretary at the time, whose name shall be anonymous here, said, we'll have fully autonomous cars everywhere by... Didn't happen. And as of 2023, Elon Musk is still kind of the only, big tech person who keeps making aggressive predictions, saying that and he said this every year since 2017, that we'll have it by next year. Wherever I worked, the problem when you were behind on doing something, the statement was always, I'll have that in 2 weeks. It was in 2 weeks. So I don't know what it's like where you work. The software still has not arrived. In fact, from May of 2021 to April of 2022, and that's the most recent data I could find that's been published by official sources, there were 400 crashes of these machines, driving machines, and 200 and something of these involve Teslas, but Waymo's Google's car division. All right. And of course, one killed a woman. This sets this type of technology back a lot if you kill somebody with it. And this happened to a lady, I think this was in, oh, what town? Starts with a T, in Arizona. Yeah, that one. So, but anyway, here's one example. The machine knew how to recognize somebody who was on a bicycle, and it knew how to recognize pedestrians, but the machine didn't know what to make of someone walking a bicycle across the street, which is what this woman was doing. Getting a machine to comprehend the difference between a flock of birds dashing across the road versus a bunch of leaves blowing across the road. Do you see how this is difficult? Because it's not just image recognition, it's real-time image recognition. And that makes this difficult science. Many of the companies that are involved with self-driving cars have scaled back, and some have outright abandoned their ambitions. When I did that conference in Ireland in 2019, Jaguar had a division in Galway that was doing AI work. I don't know what their status is currently, but Ford and Volkswagen have pulled the plug on their joint effort. Tesla, aside from Tesla, most automobile makers, and I think this is who Mercedes relies on, is Mobileye, an Israeli tech company that was spun out from Intel. And many researchers say this is big money. I mean, there's a lot of money still going into driving automation, but no one is very optimistic about when we'll have this. Right now, 2030, they're still won't have it. That's what, 7 years from now. All right. Let's look at ChatGPT as another use of AI. And you saw how well self-driving cars has been going. All right, for those of you who aren't familiar with it, ChatGPT is a natural language, and that's what I'm presumably using to speak to you tonight with, is natural language processing tool. It's designed and built by a company called OpenAI. This is their little logo over here. It's a conversational chatbot. That means it's a robot, a computer that can carry on a conversation. It can do it in text, it can do it speaking. It's of the generative pre-trained transformer family. So for those of you who didn't know what GPT stood for, there you go. And we'll talk about each of those words in just a minute. It's the latest tool in automatic text generating AI products. It follows instructions in a prompt that you, the human, give it, and it gives a detailed response, and then it can do follow-up. So in addition to just responding to a prompt, you know, like a search engine does, you enter in a question to a search engine, you know, like figuring out the answer to a crossword puzzle or something, you give it the clue and it gives you the answer. This chatbot is designed to follow up and to stick to the topic or be able to make changes that make it sound more natural, more human in its response. All right, it can help you compose emails, essays, code, reports, all sorts of things, but it has a lot of competition. And here are the logos of a number of the companies that also have a chat bot because that's what Chat GPT is, have a chatbot product on the market of some form. Now, CNN made a note here that ever since it was released, of course, this is now in the spotlight, and this is typical of news headlines, sparking enormous excitement. And there I use my news voice for that. That makes it more important. All right, ChatGPT, along with other AI tools, racked up 100 million users in 4 months. No other online app comes close to that in terms of its growth rate. So this has become popular fast. And people use it to write emails, plan their vacations. Paul McCartney's used it to produce a song that has John Lennon's voice. Now it's using John Lennon's recordings, you know, his actual voice, to learn his voice and imitate his voice. And these language models can do that. You can find an app online where you can go and talk into a microphone like I'm doing and really not say a whole lot. And the AI will learn your voice and then be able to read anything in your voice and sound like you. All right, so it can be used to impersonate anyone. And the visual tools, the video and image tools that are out there can do the same thing and create images that look like you. And we'll talk a little bit more about that as we go. Okay, so let's first talk about GPT. Generative is what the G stands for. It means that it's a computer model, a neural network that is designed to generate new content, but it's expressly programmed so that it does not duplicate or say exactly the content that it was trained on, so that it sounds more intelligent. It paraphrases what it's learned, so to speak. The word pre-trained means that the model's just been trained on vast amounts of data, which is true for all neural networks. Not sure why they even need the P there. It's kind of assumed. But Chat GPT, there's the P. And transformer, this is the interesting part, and this is the foundational part, is the transformer architecture. This is a neural network that has mathematics that allows it to do the self-adjustments, but it has an additional feature that was developed here about 2017. And it's called an attention mechanism. And the attention mechanism allows it to properly weight the features in a sequence. So most of these networks are, you see these words here, sequential data, right there, sequential data. Language is sequential data. One word follows another, right? Video is a sequence of images, all right? Music is a sequence of notes and sounds and sung words and so forth. So what for language is, it matters what words, the words are not all of equal importance. So if you have a language like Spanish, for example, where you have to match the gender of the verb with the noun. So if it's a feminine, say ending in an A type of sound, then of course you have a particular verb format that has to match that. So the attention mechanism is designed for the computer to notice these features in the sequence of information. And that's been the key. That's what makes it a transformer rather than just a deep learning network. Now, generative AI itself is a foundational computer model. So I've gone back to the G, the generative part, that's designed to generate the things it's been trained on. Artifacts include things like language and images and video, music, and so forth. Those are all called artifacts, and it's all sequential data. These artifacts reflect the training data, but they don't repeat it. So a generative AI can produce a new image, a new painting, a new video, and it can compose music. It can generate software code and text and product designs. Here's kind of the journey to generative AI, which is the real key thing that the transformer has enabled. And notice the language that's used in the blue boxes. First, there's near perfect translation. There are a great many human translators who would contest that even today, but the models are much better. They're quite good at this point, but near perfect is some quotation marks needed there. Mastering the meaning of words. There's another human word, meaning. These machines don't know jack about words, okay? They have no perception of meaning. They simply know which symbols, called words, are related to which other symbols, all right? They basically have read all of Roget's thesaurus and the same kind of a thesaurus in every language that they are trained on. And they know what words are related. So meaning is an interesting term. They are good at matching words so that they give the impression they understand meaning. Then you've got your large language models, which are built on the transformer architecture starting around 2017. And today we have these large conversational large language models. Now, there's a great deal of math, enormous computing power that's required to train these models and do the various mathematics that are involved to set all the parameters. But they are all, in essence, prediction algorithms. If you say, what are you, and then you leave a blank there, right? Well, what are you doing? Well, doing would be a word that could be predicted with a high probability to be the next thing in the sequence. What are you doing? What are you listening to? Do you see? The machine learns, well, what types of words would come next in a sequence? And it adjusts the parameters so that its prediction capabilities are very good. This is how it learns. All right, and let's talk about the transformer in a little bit more detail. It's a neural network with the attention mechanism that I mentioned so that it understands how to properly weight elements of a sequence, such as particular words in a sentence. And as I've already mentioned, computers don't understand words. No such thing as words in a computer. It's ultimately ones and zeros, but they work best with numbers, vectors, and matrices. So words are converted to a vector. And then the transformer architecture replaced what was popular at the time, which were recurrent neural networks and the long and short-term memory neural networks. So that's what's made all this so popular and successful, has been the attention concept that was introduced. Now, all these chatbots have known problems, and these problems that I'm going to show you are right off of OpenAI's website. Okay, so I'm not making these up. It's not me being, hard on them. It's themselves telling you, here's the way it is. First of all, it can produce plausible sounding but incorrect or nonsensical answers. And there's a term for these wrong answers. They're called hallucinations. Seriously, this is another human anthropomorphizing. Is that a big word? Making a machine appear to have human characteristics. And, Hal, open the door. So now, they say that ChatGPT can often be excessively verbose and overuses certain phrases. I know people like this, and you probably do as well. Its proficiency largely depends on the quality and the clarity of the prompt. Now, the prompt is what you as the human put in. So what they're doing is they're blaming the user, in my opinion. You gave us a bad prompt. That's why you got a bad answer. But that's on their website right there. And ideally, the model would ask clarifying questions. That means if it really had some intelligence, it would ask clarifying questions, but it usually tends to guess what you intended like someone with bad hearing listening to what you said. Now notice what ChatGPT is not. It is not a secure channel for sensitive information. So if you start giving it your personal information, you're giving that away to somebody else, likely not somebody you would want it to go to. It's not a reliable source for legal or medical advice. I don't have the reference here, but you can go Google this. A recent legal case was discovered to have legal references, in other words, court cases that it officially referred to that it got from ChatGPT, and ChatGPT made them up. They weren't real court cases, right? Because it can't distinguish whether it's paraphrasing versus it's making something up that's not truthful. And we'll get to that word truth here in just a minute. It is not a substitute for human decision-making or professional mental health support. So like I said, if you're talking like it's your friend, you need some professionals. It is not a precise mathematical tool. So even though it can respond and it can do math, don't count on it being correct. It may have misunderstood you, or it may be doing a calculation that's not what you really asked it to do, or you think you asked it to do. And it is not a source of truth, because this is right off of OpenAI's website. Quote, "There is no source of truth." Thought you might find that to be an interesting statement from the tech world. Okay. Now, I think recently the UN has set up a evaluation, what's it called? Fact checking. They have a fact checking system. So maybe they're pretending to be a source of truth now, but at least on the internet, this is a problem for the technological world. Is okay, how do you determine what's true? All right, now, what if people start using this as a source of truth? In fact, people have been doing this before ChatGPT came along. They would say, well, I Googled it and it said, fill in the blank, okay? Because after all, the internet is the source of truth. That's where you go find out what's what. But for those of you who've done searches and looked at the kind of results that you get, that you have to wade through to try to find something of value, you realize there's a great deal more, we'll call it non-truth or some other word, that's out there that you cannot rely on. So what are the consequences when people start using these natural language chatbots as arbiters of truth? That's a new problem that we now have, more so than we had it just with search engines. But it's just, it's the same kind of problem. People relying on, well, I Googled it, must be reliable. Many companies see AI, and especially these large language models, and LLM, by the way, is the acronym you'll see in some literature for these chatbot models, as it's the answer. We've got to use this no matter what our industry is. Here's an example. When AI language translation tools came out, and this was before ChatGPT, they quickly displaced people hiring human workers. My wife, Celine, she speaks Spanish well and can edit and, check your work, so to speak, in both English and Spanish. She used to do this for Lowe's companies and other businesses. And she could always tell when a machine translated something. Now, the machines are better than they used to be, but as this writer says, Shockley here with Malware Bytes, yeah, the AI tools were cheaper and people were quick to grab them, but the quality of the translations, that is, of the truth of it being correct, was worse. Google, now let's move on from ChatGPT. Google has a competitor and they've got their new product, which their CEO says will surpass ChatGPT's capabilities. And here's how we're going to do it. We're going to use AlphaGo, which is a particular AI tool that could correct its mistakes, so to speak, to learn to play the game Go. And they're going to combine that with GPT-4, which is, I think, the most recent released copy of the GPT model, and reinforcement learning. Now notice he's only got one unique thing there out of those three, and that's AlphaGo. Google owns the AlphaGo techniques, but the GPT-4 model is open source from OpenAI, and reinforcement learning, everybody does that. So I'm not quite sure what he's bragging about, but these are the claims, marketing claims that come from the competitors. All right. Now, there's a human cost. This is the part where we're going to pull back the curtain and see what Toto has shown us. All right. Human intelligence, of course, is the basis of artificial intelligence. That's where the intelligence always comes from originally. And these machines depend on people as much as they do math. In fact, Google's search engine and their ad system and ChatGPT's design use thousands of human raters to assess the quality of their AI-driven search results and to help identify scam ads and to provide the machine feedback so the machine can adjust its parameters and predict better. Facebook, of course, asks you to label their photos and give it human feedback. So all of this deep learning requires extensive human training on hand-picked data sets. So behind these impressive AI systems are huge numbers of people labeling data to train the machine. This is the job called data annotation, or there's a specialized version called data curation. And you can go Google this stuff, and you're about to get exposed right now to how vast this is. Little is known about the information shaping these systems' behavior, about the data that's used to train the AI. And even less is known about the people who are shaping that data. And the companies that do this, only the companies that can afford to buy this labeled data can really compete. And they're highly motivated to keep secret who they use to help with their data labeling. This is a big industry. Don't look behind the curtain. No, we can't tell you that. Sign the NDA here, before you can work for us. So these convincingly human-sounding chatbots have all started with a huge effort of tedious and repetitive human labor. This is called human feedback data, and it's currently still a foundational part of making AI systems, even though the engineers want to think that it's just a passing inconvenient prerequisite to the more glamorous work of building models. And these words, by the way, that I'm using come from this article in The Verge that's referenced down here at the bottom. But there are a number of writers who will tell you about this. So this data annotation is infrastructure for AI. It's big business. You got the Kenya and Nepal-based companies. You can earn $1.20 an hour. $2 an hour from Sama AI, crowdsourcing companies called Mechanical Turk and Clickworker. And then you got Scale AI. Scale AI was founded in 2016 by Alexander Wang. His company's valued 2 years ago at $7.3 billion. And all his company does is data annotation and data curation for the big cloud service providers. So if you think AI is a brilliant thinking machine, look behind the curtain and you'll see that it's very much Silicon Valley, where you've got a gleam of new technologies, but this sprawling manufacturing process with millions of data annotation people being paid modest things to make it run. None of these companies will say how many people contributed to their models, but there are millions of people employed in data annotation. You thought AI was going to put people out of work. It's employed millions in data annotation. All right. And many of these companies that are out there may appear to be owned by the same company, but they all create subsidiary corporations to hide who each company is getting their data from. So this is all just so your competitor doesn't steal your stuff. Put another way, ChatGPT seems so human because it was trained on human writing. It's mimicking human writing. It's rating feedback from humans who are rating how well it was mimicking humans. You got that? This is called reinforcement learning from human feedback. And if you listen to any of the news or the interviews of the CEOs of these companies, they've used this term, RLHF, reinforcement learning. It's so effective that we need to pay attention to what it does not do. When an annotator teaches a model to be accurate, they're not checking the answers against logic or against an external reference or about what even accuracy as a concept is. The model is still a text prediction machine, mimicking patterns in human writing. And these corrections help it adjust its parameters to improve its predictions so that it strings words together that humans say sound better or are more correct. And this particular writer says, okay, this may maybe make it align with the truth, but it can also make the machine mimic a confident style and expert jargon while saying things that are totally wrong. So it can be a baloney factory, all right, that sounds very confident in its answers. Last thing on this topic is that Google is going to use everything you've ever put online. I'm not making this up. This is straight from the news, to train its own AI. Let's say they could use it, and it's a part of the end user licensing agreement if you have a Gmail account or any other Google product. After all, how much are you paying for Gmail? Nada, right? And this is what we've given up when we use free products. Like, how much do you pay for Facebook? Nada. So there's a price to be paid, and the price is loss of our information or making it fundamentally public. And all of these companies, it's not just Google, they're all doing this. And as a result, in the last 2 months, there have been class action lawsuits against OpenAI for ChatGPT and Google for their products. All right, and Amazon will be next and so forth, for basically stealing personally identifiable information without consent and so forth. I'm interested to see how these go, because these end user licensing agreements are one of these things that we all click on to say, I accept, click, to use the free software. And what you're accepting are these things that they're actually getting sued for, in my opinion. I'll be interested to see if these lawsuits stand up, but I'm not optimistic, because we've all given up our rights to our data by using these cloud storage facilities and Facebook and Twitter and so forth. But you got these AI tools, you know, falsely claiming people written an article or a court case that doesn't exist, and they're running into copyright trouble. And this particular writer said that there's no way to know if these tools are actually really improving anything. Plus, you can use this type of AI, a chatbot, and the video tools to create spam. You can create an email, you can create voicemail, you can create a video of what looks like, again, your mom talking to you into the Zoom camera and telling you that she's in trouble and needs you to send her money. And people do this, all right? You can get a phone call and it sounds just like your grandson, you know, or your child or your parent, and they're telling you they're in distress and they need you to send them money, or whatever else the scammer's trying to get out of you. All right. So AI just makes spam and scam faster and easier. In fact, there's a website called newsguardtech.com. you can go, the last I checked, which was yesterday, but they still said that there are 331 unreliable AI-generated news websites. These are websites that claim to be the news, but no human wrote anything on the website, or very little. So these are called generally content farms, and these are proliferating rapidly using AI, ChatGPT generated content. And once again, the reliability of it and who's doing the homework checking, possibly nobody. So I'm running out of time. Let me try to finish up here. Is this intelligent? Well, so far, humans are still better at telling a mosaic from the same image on a blanket, all right? And many technical writers and scientists say it's going to be a long way before these machines can really do human level discernment. Now, they still claim it's a temporary embarrassment, but temporary could extend for decades. At its core, AI is incapable of comprehension, knowledge, thought, or actual intelligence. This writer with Review Geek says it's little more than a marketing gimmick, in his opinion. And of course, there's nothing easier to sell than a product that has a name that you think you know what it means. Artificial intelligence. Oh, yeah, that's great. But the problem is it's not intelligent at any level. And corporations aren't interested in correcting the public's misconceptions. Please invest in our company and our AI and so forth. Now, maybe it is a good investment, maybe it's not, but this particular writer, and this is a recent article, is really coming down hard on the overselling of what's going on. And of course, Gartner said we're at the peak of inflated expectations. Stuart Russell, professor of computer science, says that a lot of people are excited about these large language models. They're an AI product, but they're not AI. This is somebody that at least knows the computer science side of this thing. We think these large models are a piece of the jigsaw puzzle. We just don't know which piece that is. Right? It can solve all sorts of problems, and Microsoft developers want to claim it's an early form of artificial general intelligence, which is what AI used to be. AI used to mean that the thing was truly intelligent like a human being, but now we have things that give the appearance of intelligence without it actually doing any thinking, reasoning, or logic, so to speak, whatsoever. Maybe 5-10 years away, Anthropic says. But Russell says if you strip out all the grammatic, because the machine is going to be better with grammar and spelling than you are, okay? Those things are good. It's got the reference for that. It's checked the proper spelling of every word and so forth. It's going to sound good, but if you strip all that away, how much intelligence is left? He says we can't inoculate ourselves against this effect of perceiving it being intelligent versus it really being intelligent. And meanwhile, you got billions of dollars going into, he's now calling neural networks old-fashioned, that don't really work right in the long run. They can produce wrong answers and perhaps catastrophic consequences, in his opinion, which leads us to concerns about AI. All right. Superintelligence was a book written by Nick Bostrom, and you've got all these warnings, and you've heard many of these. I won't spend a lot of time on them, but it poses a danger. All right. It's worse than nuclear weapons. In fact, humanity could become extinct. There are a lot of voices who've been saying this, although they've been saying it for many years. Okay. And of course, central to this is the so-called singularity and intelligence explosion, which is when the AI could improve itself and become allegedly more intelligent than any human that's out there. All right. Musk even is invested heavily in this, as it's could be more dangerous than nukes, and that we're really already cyborgs because we're all carrying a phone around, right? Don't you have, all of you got your smartphone with you tonight, right? See, so you really already have technology embedded in you practically. The only difference is that, we just need to go ahead and embed this in our brains so you don't lose your phone. Stick it in your head. But he also said, we're summoning the demon. Yet he's just last week announced he's starting a new AI company. 2000, of course, there are a lot of people crying, doom. Here are organizations that have popped up, all right, warning about it. Ray Kurzweil says the singularity is near. That's his book that came out some time back. But a lot of this is that we're hearing from it. Hawking, before he passed away, said, are we taking this seriously enough? 2016, the Partnership on AI was formed, and they're trying to be sensitive about the problems. And some of the problems are biases. This is the current thing that people are pointing out, that it's patriarchal. It's because it's got a male bias, or it's got a particular people group bias, or whatever. So this is a problem, and it may be a problem because depends on what data you used and who trained it and how they trained it. They're products made by human beings, all right? And human beings have biases. So there's a call for greater regulation. The regulations aren't keeping pace, even though there are safety organizations. In other words, the industry's trying to police itself first. But calls for greater regulation from scientists. They've all issued a letter here recently calling for greater regulation. And some people say this is like the atomic scientists issuing warnings about the very technology they created. All right, and so forth. A lot of this kind of stuff. The EU's got the most mature, I guess you call it, legislation in process. They've categorized low risk, medium risk, high risk software, and so forth. All right. Lastly, Human 2.0. So this is a very popular author right now. You've all Noah Harari. If you've not heard of him, just walk through a bookstore and newsstand and you'll see his books. Heavily promoted right now because he's doing a lot of work for these global organizations such as the World Economic Forum and so forth. But notice this guy is not a computer scientist. He's not in the computer AI technology. He's a history professor and whatever a futurist is. All right. But one of the words that has come up is this word transhumanism. All right. There's a logo for the transhumanist cause. That's the logo there. And he says things like, we'll have the power to re-engineer our brains and our bodies. In fact, the machines will be so good, they'll be better than us, that we'll want to improve our own bodies. Instead of having a normal leg, we'll want to have a machine leg. We'll want to have a robotic body, and this kind of talk. And you have words like this that become popular. We've hacked the operating system of human civilization. Now, if you drill into, well, what do you really mean by that? Which people haven't questioned him on this yet that I've seen. These are popular words and they sell books, but it also causes those who aren't familiar with the technology to become concerned. Transhumanism, let's look at some terms, is an intellectual movement that wants to improve or transform the human condition by using technology, right, to create Human 2.0. Many of these transhumanists are those who are a part of this intellectual movement and singularitarians, I guess it is properly pronounced, basically believe that through technology that the potential of becoming immortal could exist. And a subset of transhumanism is called extropianism. And of course, they think that eventually, through the use of science and technology, people will someday be able to live indefinitely, live forever. By the way, this word extropian comes as the opposite of entropy, which entropy means increasing disorder. So extropy is increasing order, that would enable us to do this. There are a number of movies that embody this kind of thinking. If you've seen the movie Chappie, all right, that happens at the end of the movie. He uploads his friend's brain to the machine so he can, in a sense, keep his friend with him or alive and through the machine. Alita Battle Angels, a similar cyborg type of a concept, and famous scientists have put things up even on science. Now, by the way, those of you who've heard me do science talks know that one of the questions I ask is, how do you tell today the difference between science and science fiction? And I've actually asked this question to a room full of physicists at Ohio State University, and no one wants to answer that question. Nobody. All right. Because we know what the answer is. You can't tell the difference, can you? It is so blurred that that's where we are. An example of this type of transhumanism in action would be Neuralink, and there are similar companies that do this, where we're trying to basically improve on the human mind. Or he backed off a little bit and said, well, we just need a brain interface to help people with brain-related disorders. And of course, you can use electrodes and various techniques to reduce, for example, the shaking effects of diseases like Parkinson's and so forth. There are a lot of things that can be done from a medical perspective here, but most of these visionaries see something far beyond just improving a degraded human condition of some kind. All right, and this was Musk's most recent statement, that we want to more tightly couple the, quote, collective human world to digital super intelligence. All right, Synchron is a competitor to Neuralink, and they actually have embedded computer brain interfaces. They first started this in Australia, and they're doing this now in the USA. Jaron Lanier, a Microsoft guy, though, takes a kind of a contrary view toward transhumanism and says that this is not really just a technology debate, is his claim. It's not an honest conversation. He says it's really about religion. It's people turning to metaphysics to cope with the human condition. And of course, they have a way of dramatizing their beliefs. And as he puts it, one does not want to criticize someone else's religion. So it's hard to have an honest conversation about it when people's views of technology go from just being science and technology conversation to something now that's gotten into their worldview, their belief system. And of course, others see this fourth industrial revolution. This is a new book that's being marketed, Dark Eon. They see it. It's not good. It's a mutation driven by scientism, which is a view that science is all there is and is what will make everything better. But they see it as a war on humanity rather than progress. So you've got different views here on this. And of course, extropianism wants to direct human evolution, eliminate disease. That all sounds good. But immortality is mathematical, not mystical, according to Kashin Tanani and others who are supporters of this intellectual effort. And of course, the idea of uploading your mind to the machine, that machines will be capable of thought and consciousness. So this is why they support artificial superintelligence or artificial general intelligence to achieve these goals. And Ray Kurzweil is one of the big proponents of this. He's been saying this for many, many years. He's director of engineering at Google currently, but this idea of uploading your brain and you'll be immortal and so forth is out there. So let's finish up. What's going on? Well, we've made significant computational gains in human assistance applications, but many writers appear to be glossing over the human effort that's put into these, trying to make you think that the machines kind of learn on their own, which is not the case. There are massive increases in machine automation for text and voice image recognition and so forth, but there still seems to be a lot of oversimplification of what is intelligent what is learning, all right? What is consciousness with respect to these machines? There are a lot of improvements in pattern recognition, but there's a lot of overstatement, even wild claims on what has really been achieved regarding machine autonomy and its ability to learn on its own and so forth. So despite all this hype, the human brain is still the reference point. So let's consider the limitations of AI. What's the word, Ross? They got neurosurgeons and neurology type people say the brain consists of about 86 billion neurons. Each one has many connections, so that there are at least 1 quadrillion connections in a everyday average brain, I guess. And the scientific community divides functions such as decision-making, emotions, perception, vision, language, etc., into different portions of the brain or that type of thing. But where conscience or sentience is remains an open question. That's how scientists say we have no clue. And if we can't really understand this writer, Mavic, down here in the reference, he says, why are we cutting and pasting plots from sci-fi flicks into reality and imposing that on machines when they're not even close to these capabilities? So does it mean it's time to brace for the singularity? All right, when things run away and we have some kind of terrifying consequences, the machines wipe out humanity? Or is AI bringing us a new utopia where machines do all the work and the humans have a life of total leisure? Neither just yet. Neural nets are good at recognizing patterns, sometimes as good or better than we are, but they cannot reason. This is a big problem from a legal point of view. When ChatGPT tells you something and you say, how do you know that? It can't answer the question, all right? There is not the ability to get at how did the machine get trained to say this or do that. So artificial general intelligence, really mimicking human reasoning and intelligence, remains far off. We were a lot of strides in machine learning, and we've had these large language models that came out last year. So that's certainly what's happening. But can software fundamentally rewrite itself? Nobody knows. But in the history of computer science, no programmer has ever created code that can substantially improve itself. So last slide. What to expect? Here are some views. As computational power and data storage continue to increase, AI applications will also, because that's what's driving the ability to create these applications. But expect it to continue to ebb and flow. Everybody's all excited right now about these language models. Let's see if they live up to the expectations, or as Gartner Group says, you're going to have this big crash of disappointment. Could go either way, we'll see. You'll still have breakthroughs in machine reasoning capabilities, and AI and automation is going to replace some human jobs, and at some point, maybe it will be like nuclear power and it'll become an issue, you know, of man's survival or something, maybe sooner than we think, but we don't know. So thanks for listening. You've been very patient.
Someone said the Apostles' Creed was translated
by artificial intelligence, and they came up with a new creed, and it isn't recognizable by my estimation. And I just wondered if you heard about this and
Yes, and I can't remember which author it was. Maybe it was Yuval Noah Harari or Ray Kurzweil, one of the two of them. You know, they think that AI should rewrite the Bible. It should rewrite 10 Commandments and so forth. And so the Apostles' Creed is although I hadn't heard that in specific, it doesn't surprise me whatsoever, because it's text. It's a sequence of words that the machine can figure out words that are similar and rewrite it and say it in different ways, or create something new from it that would look that way if someone asked the machine to do that. So it's an automatic text generating machine that's going to build on whatever has been on the internet that it was trained with, and the type of content that's in the prompt or the question, the instructions that it's asked to do. So humans can, it's like any tool, humans can use it for good or other purposes.
Ross? Can you hear me?
Yes, ma'am.
Yeah, I'm by the mic. I asked you previously, before the program, can the spiritual dimension of demons affect technology in terms of taking control of technology?
Well, there's a bigger question, if I might respond perhaps this way, is there are those who believe that the spiritual world, in particular the demonic world, can take control of a variety of things, most importantly, human beings. And certainly there are examples of demon possession in the Bible that we know about. But the degree to which it can take charge of inanimate objects, material things, throughout history, there have been alleged examples of that. I can't confirm or deny them. I'm just simply saying that if indeed that's the case, then the easy answer to your question is, yeah, of course they could, if they can control inanimate things and have the right or ability granted to them to do so. But I don't know that for a fact, and I don't know that I could speak any more intelligently to your question than that.
Thank you.
Yeah, so I'm noticing with the words neural networking and some of the things that you showed composition for the networking, that it's somewhat mapped out like pharmaceuticals or drugs. So I'm wondering if you believe that that could possibly be a representation of sorcery also, that artificial intelligence.
Well, AI tools are being used directly, and there's plenty published on this by pharmaceutical and drug development companies for drug design. Now, that's slightly different than the question you're asking. Okay, of course. But whether we as Christians would define it as sorcery, alchemy, etc., we could do that before there was AI. So AI is, in many respects, merely an amplifier of what humans have been doing and intend to do all along. That's how I'd see it.
Early on in your talk, you mentioned governments or controlling bodies are slow to come to grips with some of the restrictions on AI. What seems reasonable and what seems unreasonable for control of artificial intelligence?
Well, that is the loaded question, isn't it? Your question is fundamentally exactly what legislators and these large organizations directly argue about. What is reasonable and unreasonable? How do we measure it? If it's technology that's still being actively developed, you can't create laws to regulate something that you don't even know what it is or how to describe it yet, because it doesn't exist yet. And regulating the computer technology that we had before these large language models, just regulating the internet alone, is something that governments have struggled with. Some would say have failed at, Others would say, especially in the EU, that they've got better protections or restrictions, at least against privately owned data and information, than we do in the US. So I don't know that I have an answer for you, because it's the issue that's argued, and measuring and describing what AI is, especially if you're using legal language, is very difficult right now, and that's part of what they're struggling with. Just a week or two ago, Chuck Schumer, one of the senators, made some public statements about a committee I think that he's a part of that's looking into the US government regulating artificial intelligence in some way. And his remarks were, hey, we're struggling with this. We don't even know how to describe it, that kind of language. But then he said, but we've got to protect people. We need to find ways to make these things explain themselves and be truthful. And I'm paraphrasing him, of course, but that was his intent. And right now, if you were paying attention to how these neural networks are developed, there is no path of explanation back through the machine. Okay, that's why it said what it said, or why it came up with the answer that it came up with. It's a pattern generating machine based on probabilities of words that should go together based on the query. It's pattern recognition techniques. It's not thinking. You can impose rules, all right? And of course, rule-based techniques are an AI technique for a different type of, the inference engine systems, but you can impose rules on software that says you can't say things like this, and you can't talk about that subject or that politician or this issue, So there are, in a sense, human hard-coded rules that can be imposed on top of it. But the actual neural network, the thing that learned how to create words and speak, Chuck Schumer doesn't realize how these things work, and I wouldn't expect him to. Okay, that's okay. It's just that as they start to grapple with this as legislators, they're going to discover how difficult the problem is to even describe this technology, much less make it do something a particular way. That's how I see it.
You can't put a computer under oath.
Yeah.
We're struggling doing that with humans. Yeah.
Yeah, I had a question. I experienced some of the chat GPT as an instructor for a PSEO class this spring for the first time.
I'm sure you did. Yes.
So the whole artificial intelligence and ethics has been something that's really been on my mind lately. And so it's trying to figure out how to do a research paper, but not do a research paper, and then trying to incorporate these assignments so that it's not so easy for students to just shoot out a paper and hand it in with these tools now that are available to them. And so my question is, do you have any thoughts as to how to challenge these students, whether is it changing assignments to a more opinion-aided assignments? Does that help kind of flush out these? No?
No.
What are...
The machine can generate opinions just as easily as it can generate alleged facts.
So does it have any place in a student's life legitimately, or should it just be, I mean, is there any way to counter this? It just feels like a wave washing through colleges right now.
Well, God bless you, and I feel sorry for you in your particular situation. I've taught at the college level. I taught at the U.S. Naval Academy for a while, and at Vanderbilt and Georgia Tech. But wouldn't want to be in your shoes. It's a difficult problem because it's no different than the problem of, you know, plagiarizing and outright fraud, you know, of having references that don't exist and so forth, which humans have done for decades. But the best I think that someone could do who is requiring writing or written material from students is to try to require references. You've got to have legit, I can look them up, references for the things that you claim, the facts that you state, some backup for the opinions that you came up with, rationale. Machines are not real great at rationale, okay? They can spout out words to explain things, but they may or may not be correct. And the key is to try, the best you can do is to try to catch out a student who didn't read the stuff the machine generated for them. That's the low-hanging fruit that you would have, would be as an intelligent person, you can detect some obvious mistakes and you can tell they didn't even read what they wrote. But beyond that, I think it's a period of time where it's going to be a struggle until these machines, one, either get better, which will make the problem worse, or they get more discredited, because that's what's happening right now. ChatGPT is starting to collect discredits for missing the mark, for its hallucinations, for information that's blatantly incorrect. So I don't know that I have more to offer you right now.
Thank you.
Do you think that digital currency and AI are going to combine together? Some kind of system?
I do.
Well, certainly possible, right? I mean, you can see how, I mean, AI at this point is still a computer technique. It is a tool, and it can be trained to do a variety of things, both good or bad. So to me, again, I view it as an amplifier of human activity. If humans have intent that is good, they can potentially use this AI neural network stuff to do something good. But humans are known to have other intents, and it's an amplifier. It will amplify those intents. That's the real warning about AI, is how humans are going to use it. I don't expect any machine to have autonomy and take over the world on its own. I mean, to take over the world, it would have to be physically connected by somebody to the things that could control the world, right? So it's like having the smart device in your home. You have to physically connect it to the lights and have smart lights that would respond to the machine. Things have to be connected to the machine for it to control them. So there's a great deal of science fiction and warnings and fear mongering that's based upon pretense that doesn't have much reality behind it right now. And I hope you've figured that out from the talk as I was going along. But can humans do powerful things that are not good, and the machines amplify their ability to do that? Absolutely.
If you're listening to somebody speak and you don't hear some of the words, your mind fills that in. Or if you read something and your mind can change some of the words to put in, make corrections, I should say. You're working with, what did you say, 86 billion neurons in your brain? How is that any different than AI? What the AI does? Your mind is doing the same thing.
Well, it's doing the same thing from one perspective, and that is that they're analogous. It's similar. But first of all, the human mind is a network of interconnected things. It is not a layered directional path system. All right. So these computer networks really don't mimic the brain, frankly, whatsoever. all right? And neurons can store information. They can we have no idea how many parameters, so to speak, each neuron has. And 86 billion neurons with a quadrillion connections is still beyond the capability of the computing capability of the world right now. So your brain is still, as a computer, as an interconnected information storage and processing device, is far beyond quantum computers or any other kind of computer. But humans like to compare them and claim that because the machines are fast or really good at certain things, that they're better than we are. And they're not even close. But what humans can do with computers can still be powerful and dangerous. But I'm not going to give any of these neural networks any credence to be anywhere close to a real human mind. So apologies, but they're not even close yet.
Maybe one last.
You see any social dangers to our children as far as like Snapchat, My AI, are things that we should be concerned about?
There are a number of writers who have addressed that, and you can do a search, on that type of thing and find some specifics where there are scammers and people who try to lure children, where there are those who pretend to be you, your parent, their parents, or something else. Children are susceptible to certain frauds, of course, the same one adults are, but even more. So there are some good writers out there that could address that question better than I can. I know that there are concerns, and that with AI and the ability to mimic the human voice, and I'll give you an example. This is not specifically children, but it could be applied. There was a episode of these singing shows. I'm drawing a total blank now on them. With Simon Cowell, listening to somebody sing. America's Got Talent. There's a good example. There's a show like that. And the artist put 4 people who could sing up on the stage, gave them all a microphone, and put a camera on each one of them so that you saw each singer's face on 4 separate screens on the wall, just like you see my face right now up on the wall. All right. And then what they did is they had recorded some of Simon Cowell's voice, and the next judge, all 4 judges, male or female, didn't matter. And the machine had captured enough of their facial image that as the 4 humans sang on the stage, what you saw on the screen was Simon Cowell singing for number 1 and judge number 2 singing for number 2, with their voice sounding like their voice. So they were live, real time, reproducing the moving face of someone who was not in the camera and the voice of someone who was not on the camera or the microphone. So that was their show, was to show you how they could duplicate somebody else saying anything. So you could take any politician and create a video of them saying whatever it is you want them to say. All right. And this is the danger. So it's a danger to children, but that same danger faces us as adults and those who wish to misrepresent reality to us. Sobering, isn't it?
Yeah.
Well, thank you very much. This was amazing, and it's going to be, I'm sure there'll be a lot of hits on YouTube, and perhaps your PowerPoint can also be made available to people who ask for it. Technology is amazing. We can spread the gospel all over the world. It can also spread evil. And, we as humans are susceptible to optical illusions. We see what's supposed to be there, not what really is there. And it looks like machines can do the same thing, and they create artificial realities.
Well, you've been very patient. I had hoped that I would get that presentation done quicker than I did. So thanks for staying and listening to it, and I hope it's been helpful to you.
Yes, thank you.